So look at the first one. I want to do the asymptotes first. There are two of them. What are they? And it's going to be x equals. Can anyone give me the first one? Not 3, but, and why is it -3? Make it 0. You can't divide by 0. Remember I called them the troublemakers? Kick them out. What can the troublemakers become? Because they can either be a vertical asymptote or what's the other thing they could be? A hole, but nothing cancels here, so they're not going to be any holes. So vertical asymptote, we have x equals -3, and what's the other one? X equals 2. Go ahead and dot those in. Oh, I wrote it in the wrong spot and I wrote it with pen. That's okay. I'll get another. Do you need another one? Okay. Well, mine needs to be right because I'm doing the problem in front of everyone. So let me fix that. There, I just showed you how we fix mistakes when we make them. Oopsie.
What did I do?
There we go.
You did it wrong. I was right.
I can count to 3. Most of the time. All right, the horizontal asymptote, you have to compare the powers. If the numerator power is smaller, do you remember what that one is? If your numerator is smaller than your denominator, it'll be 0. When it's a tie, what do you use as a tiebreaker? Yeah, like the coefficients, just the numbers out front. And if the numerator is bigger, it's a slant asymptote, okay? So look at this one. Do you see an x in the numerator at all? No, it's x to the nothing, all right? That'll be x to the nothing. Down here, if you were to multiply this back together, x times x would give you x squared. 0 is smaller than 2, last time I checked. So this is automatically going to be 0. Now, it's kind of hard to dot that in because it's on the axis, so I know that's difficult to see. Maybe just like extend it a little bit further. But you only want to do it at the edges, not the whole way through, because the graph can go through it in the middle. It's just the end behaviors. Look at the other problems. What do you notice?
They all look the exact same.
They're the same. So if you don't want to write this on every single line, you don't have to, but can you go dot those in on all the other grids? I made all 5 of them. I know I'm asking you to do 5. We just want to do a compare and contrast. So I kept some of the things the same. Just go and dot that in on all of them because I kept it the same for every single one so that we could like compare some things. Yeah, so the x equals -3, x equals 2, and y equals 0. That's going to be the same on all 5 of these. And if you don't want to write it on every single line, that's fine, but just please dot them in because I want you to visually see some stuff here. So I'm going to make an attempt to get you to see it. Yeah, so just make them all look the same. Looks like a big H or something. Sort of like art in math class. We'll see. All right, so I kept the asymptotes in the same place for all of these. I'm just going to move around where the x-intercept is so that you can hopefully make some connections for this, okay? How do you find an x-intercept? Not even just for a rational graph, but for any graph. How do you get an x-intercept? Equal it to 0. Now, hey guys, if you took this and made it equal 0, what is the first thing you would do to start solving that? Yeah, like you would multiply these over, but 0 times anything is still 0. So you end up with 2 equals 0. Thoughts, comments on that? Does 2 equal 0?
No.
No. So what do we put? None. There just isn't one in this case. Okay. Which makes the graph kind of difficult to do because we don't have any points. Okay. But here's how you can figure it out without a calculator. Watch me point to this. You're going to have an arm of the graph over here. You have 2 choices. It is either up here above sea level. That's what I call this. Or it's going to be down here. You have a 50-50 shot. You could even just guess. You have like 50-50 shot of guessing it. All you have to do is pick a number that lives over here, plug it in, and see if it comes out positive or negative. You don't even need to work it the whole way out. Just see if it's positive or negative. Give me a number that's over here. Did I just say 3 for real?
It's negative. I'm sorry.
So what would be over here? Let's try -5. All right, are you guys ready? I'm not sure, but the numerator's 2. If you plug in -5 down here, -5 plus 3 would be -2. -5 minus 2 would be -7. You don't need to figure out what that value actually is. Just will it be positive or will it be negative? Why will it be positive? Because that's correct. Cancel. Good. So I know that this is up here. You're just testing to see what it comes out to. Now, oh, sorry, question?
Oh, was I supposed to write that?
Now we're going to test the middle part. I'm a little nervous to ask, but can we get a number that lives in this middle part here? -1 isn't wrong, like that's correct, but can we do 0? Is that okay? All right, so let me go back and plug in 0. Numerator would be 2, 0 plus 3 be 3. 0 minus 2 would be -2. Now I don't care what that value actually is, just whether it's positive or negative. So what would that come out to? Negative. So I know this middle part has to be down here. Exactly where it is, I'm not sure, but I know it has to live below sea level. Yeah, because there's 2 vertical asymptotes. Isn't that cool? So give me a number that lives over here. 3. 3 plus 3, 6. 3 minus 2, 1. Again, I don't care what this actual number is, just whether it's positive or negative. So what does that come out to? Positive. It's going to be above sea level up here. Isn't that a cute little graph? I always feel like that looks like a suspension bridge or something for some reason. Does anybody else see that? I don't know. That's what it looks like to me.
Oh, yeah.
Do you see that? I don't know. That's what it looks like to me. All right. So let's try this one. That one didn't have an x-intercept. This one is going to have an x-intercept. If you set this equal to 0, you would multiply these denominators over, it would still be 0. What do you get? Get 0, right? So your x-intercept is 0, 0. So you can go ahead and put that there. Now, for the sake of time, I'm just going to draw this one in for you. Do you feel like you could test numbers and see if it's positive or negative? Like, I believe you could do that, but for the sake of time, I'm going to just draw this one in for you. So you set the whole thing equal to 0. But what ends up happening is the denominator goes away, because if you multiply this over 0 times, like 0 sort of absorbs it. So it's really just going to be the numerator equals 0. You just get 0. All right, so this one is going to look like this. These graphs are so cute. Look at these.
I don't like that one.
Oh, I like that one. I think it's cute.
Oh.
So this part is down here. The part in the middle, it had to go through 0 because we actually had an x-intercept that time, and then this part was positive. So you have like 3 separate arms of the graph. We're just looking at what happens when you have 2 vertical asymptotes.
Yeah, but it has to be the vertical.
Yeah, it kind of wiggles there in the middle a little bit. Good enough. Yeah, I'm not grading your art skills. It's like good enough. So again, I'm keeping the asymptotes in the same place. I'm just changing where the x-intercept is. If you set this equal to 0, what will be your x-intercept? 1. Good. 1, 0. Be right here. Stop looking at me. I like that. I might use that. Stop looking at me. That's difficult for me, though. I'm in the front of the room. All right, this graph is going to look exactly like the one we just did, except instead of going through 0, it just got moved over to 1. All right, you can basically copy this over. It's going to look the same. I know, isn't that wild? It's crazy. So here's the takeaway. Whenever there is an x-intercept that is in between the 2 asymptotes, you're going to get that wiggly kind of thing. Do you see that there? That's the takeaway. All right. So the x-intercept is in between those 2 asymptotes, those 2 like prism bars. You're going to get this wiggly looking thing. Now I'm going to move it somewhere else. Oh, sorry. So for this one, if you set this equal to 0, now what will be the x-intercept? Good, -5, 0. Do you see how I moved it outside of the two asymptotes? So I want you to see what happens outside. Now, again, I'm gonna just draw this one in for you for the sake of time here, but I believe that you could pick test values and test it. This arm over here is gonna be above sea level. This part's positive. In between them, it's gonna be negative, so below sea level. And I need to watch that. I say above sea level and below sea level so often that on a calculus test, one time someone wrote that as their explanation for something, like because the graph is above sea level, don't do that.
Is that wrong?
Well, they won't give you credit on the AP exam. I knew what they meant, but you have to say is positive or is negative, okay? And then this part, it's gonna start up here, but watch. Because you have to go through the x-axis and you have to level off, yeah, that's fine. At this asymptote over here, it's going to turn around and come back. So you get this little turn in the graph because it has to go through that point and then come back and still level off at 0. That's cool. That's so cool. Neat. It's neat, guys. Now, I'm over exaggerating it. It's actually super, super, super tiny. It would be like at -0.1 or something like that. I'm like over exaggerating it so that you can see it. But here, let's try this one. If you set this equal to 0, where is this x-intercept going to be? 6. Good. 6, 0. And it's outside of the two asymptotes. It's over here now. And again, for the sake of time, I'm going to draw this in for you. But again, you could pick test numbers and see if it's positive or negative. This first part is going to be negative, below sea level. In between them, it's going to be positive, so above sea level. And then down here, it's going to start out negative, but watch. It can't just level off because it has to go through this point. So it has to go through it, and then it's going to do what? It's going to come back. It's going to turn around. So you get that extra turn in the graph. And again, it's super, super tiny. It would be like barely positive. But here's the takeaway. This is like the point of why I did this, because people get confused when there's two vertical asymptotes. If the x-intercept is in between them, what do you get? Like a squiggle wiggle, okay? And if the x-intercept is outside of them, you get this extra turn in the graph. And I put that little sentence down here. If a rational graph has two vertical asymptotes and the x-intercept is outside of them, then the graph has another turn. You're going to get that little bump in the graph because it has to go through that point and then come back down and level up. Cool, neat. I like to do this so you can compare and contrast them though, because it helps like deepen your understanding of what's actually going on in the graph. Okay, first thing that you need to do is factor this. Now the x minus 2 is not going to factor, but how would we factor the denominator? Good, x plus 2, x minus 2. So that's like step 1. Then do the domain. Who are our troublemakers? Who is getting kicked out? Who is not invited to the domain party?
2.
Good, 2 and -2. Now, how do we write that we're kicking them out? I'll give you a hint. It starts with a parenthesis and a negative infinity. Good, we have to do the -1 first. -2. Union. Good, union. Perfect. You want to do negative infinity to positive infinity, but skip over -2 and +2. You have to use parentheses to leave them out. The most I would give you is 2 numbers to leave out, but do you guys understand that in theory, the more numbers you left out, you would just keep unioning them all together. Your answer would be like this long. I wouldn't do that to you. I'm just like, in theory, that's how that would go. Now that we've booted out 2 and -2, what can they become? What are their potential career paths now that they've been kicked out? The whole or because it's missing. Perfect. How do you tell which one's which? Whole is the one you cancel.
It's a whole.
Vertical asymptote is the one that you don't. Okay. So which one cancels out? It's kind of tricky because one's 2 and one's -2, but 2 is gonna be the whole. -2 is gonna be the vertical asymptote. Now the whole is a point. It's 2 comma something. So how do we get like the something? Plug it in. What's still in the numerator? Because the whole thing canceled out, but there is something there. It's not 0. It's a 1. Good, thank you. So if you want to rewrite that with a 1 there, that can help you to see that. All you have to do is plug 2 back in. What do you get? 1/4. Do not be surprised when you get fractions. The whole problem is literally a fraction, okay? Now I like to build the graph as I figure stuff out. So I would go ahead and put those on the grid now instead of trying to do it all at once. You're gonna have a whole, like a little donut at 2 1/4, good enough, like, you know, just close as you can get it. And then the vertical asymptote is at x equals -2. Again, that's my suggestion to you. Like, don't try to do everything and then put it on the grid all at once. Like, just put it on as you find it, because then you're not trying to do everything all at once. Then I would do the other asymptote. You have to compare the powers. That's tough. What's the power in the numerator? Good. 1. Denominator is 2. 1 is smaller than 2. So what is this going to be? Good. It's going to automatically be 0. And then you can go ahead and dot that in. It's kind of tough to see it when it's 0. Just kind of like dot it at the edges, I guess. And then it would be nice if we had some points. Go back and try to get your intercepts. X-intercept, you would set this equal to 0. And you would end up with 1 equals 0. So what do you think? There aren't any. Just put none. Now you have to put something on that line. And I love you guys got silly with it. Some of you. You can put nope. You can put a frowny face. You can put NA. But you have to put something on the line to indicate that you answered it. But the answer is none. How do you get the y-intercept? There will be one, by the way. Yeah, plug in 0. Okay, so if you plug in 0 for x right here, what do you get? 1/2. Good. And so it'll be like right there-ish, whatever, good enough. And then you can draw it in. Please connect the whole to the graph. Do you remember us talking about that? If you leave it floating out in space, I will just tease you a little bit, okay? You okay? No? All right, and then you can go back and get the leftover stuff. Range, we're gonna go downwards to upwards. Who is getting left out of the range party as we scan here? 0, good, and then also 1/4. Why 1/4? So it's like literally missing. So you're gonna write it the same way as the domain, but you're skipping over, oh, not 1. You're skipping over 0 and 1/4. 0 is the horizontal asymptote, 1/4 is the y part of the whole. Increasing, decreasing, the only thing you have to remember is what direction do we read it? Left to right. Just watch me point. Hey guys, what's it doing? Decreasing. So for increasing, you're going to put none or whatever you feel like that indicates that the answer is none. What do you copy over? Boom. What do you copy over for decreasing? Domain. Just copy it over. If your domain is wrong, but you copy it over, I'll give you credit for the decreasing answer. Will you ever copy the range? No. It is left to right. And then end behavior. Limit as x goes to -infinity for the function. Limit as x goes to +infinity for the function. It's actually shorter than how you wrote it last year. It's a more abbreviated way to put it. It means the exact same thing. It's just the left end and the right end. So where are they both leveling off? And if you want to cover up the middle to help you see it, these are your ends. Where are they both leveling off? At 0. What's the other indication that those answers are going to be 0? Yeah, the asymptote's 0. That wasn't too bad, right? Y'all survived? Go ahead and try to factor number 6 with your tripod and then compare with each other. I just want you to factor it. Because that's the first thing that you've got to do.
So offended. No, look. Just tell me where I go wrong. Don't worry. We'll do the square. Well, there's two x's. So what do I write here? It's 2x squared. So 2x
Oh, wait, does this one not factor? Oh, it doesn't factor? Oh, whoops. I'm sorry. I didn't do that on purpose. I'm really sorry. Okay, it didn't work.
We almost factored it.
Okay, forget it. I'm sorry. I looked at it and I was like, oh, here, I'll just ask them to factor that real quick. I'm sorry. I'm really sorry. I'm so sorry. Okay, it didn't. Well, fine then. We get to just start doing the problem. Oops. Sometimes life's like that. All right, who's getting kicked out of the domain? 2. Anybody else? Nope, just 2. I'm really sorry about that, guys. Whoopsie. You know what? That worked out. We tried and didn't work out. All right, so 2 can now become what? The whole or vertical asymptote. Does anything cancel? No, so there will not be a whole. 2 is the vertical asymptote. Usually at that point I get asked, but Miss Cole, how did we have both a whole and a vertical asymptote for this one? Well, why were we able to have both for this problem? Yeah, and there were 2 troublemakers. So one could be this and one could be this. If you only have one number that's getting left out, it can't be both of them. All right, so let's go ahead and dot that in at 2, x equals 2. All right, horizontal or slant asymptote. Let's go back and compare. What's the power on the numerator? 2, denominator 1. When the numerator is bigger than the denominator, good. How do you find a slant asymptote? It's what kind of division? It's our synthetic division. I'm going to erase this so I have space to put it. Who goes in the little box? 2, your little troublemaker. Is our countdown in order? It is 2, -5, 5. They're always going to be short, easy problems. Bring down the 2, multiply, add, multiply, add. 2 times 2 is 4. Good, -1. And actually, you can stop there. If you don't even feel like finishing it, why? Yeah, we don't use the remainder. So this is going to be y equals, and this is y equals mx plus b, guys. Y equals, beautiful. If you remember, or if you don't remember how to graph that, just watch. I'm going to do it right now. But do you remember y equals mx plus b? Like that was 3 months of your life in algebra 1. All right, you're going to start at -1, which would be right here. And what is the slope of 2 telling you to do? All right, so from there, I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And you want to just dot it in because it's invisible. So I started at -1, I started down 1, and then your slope is to go up 2 over 1. So every up 2 over 1, I just kind of put like a little dash because it's an asymptote. So it's leveling off like this. It's cool. It's cool, guys. It's good enough. It doesn't need to be like super perfect. I mean, you can get out a ruler and do that if you want.
Oh, I did it wrong too.
No, it looks fine. Yeah, it looks good. I can see from here.
Yeah, because mine went out right here.
It looks good. You just need to finish this up.
Right.
Yeah, you're fine.
It started at -2.
No, it starts at -1.
I know. I started at
Oh, okay. Well, then just shift it over a little bit.
All right. I'm right with them.
All right, x-intercepts. We weren't able to factor this, so do we get any? No. If we could have factored that, we could have set them equal to 0 and then gotten some answers, but we couldn't. So y-intercept, what are we going to plug in? 0. If you plug in 0 for all these x's, what are you gonna get? Well, usually I'll just cover them up. Like if there's 0, they're gone, right? So it'd be 5 over -2. -5 over 2. Whereabouts would that be? -2.5. So like about here. And then you can go draw in the graph. It's gonna look like an hourglass. It's gonna do something like this. Sorry, I kind of ran into the hole in the paper there. Notice how I didn't ask you increasing, decreasing on this one? Like I just didn't even put it on there. Right? And then, well, you'd need a calculator to figure out exactly where this turns around. So I just don't even ask it. So go ahead and set up your end behavior. And if you want to cover up the middle of the graph, that will help you see the ends. Like, see how I'm covering up the middle? Where does the left end go? Down. So what will we put? Good, negative infinity. And then the right side, positive infinity. I think I'm going to pick and choose which ones we do here. I'm just going to have you guys try one. I want you guys to have time to start your homework. Let's have you do 7 and 10. Let's do 7 and 10. Do you want to do one more together and then I'll just leave you guys to do 10 with your group? Okay, we'll do 7 together and then I'm going to give you some time to try 10 and we'll go over it. I will, of course, fill out the other ones, and when I take the picture, they'll be on Schoology. This one does factor. Okay, go ahead and give this one a try. I'm super sorry about earlier. I feel really bad about that. This one actually will work. I promise, I promise. Well, how will we split 2?
No, I did. Yeah.
So 2 would be 2 and 1.
Oh, yeah, because you defined it.
And then what symbols would we need?
Plus and minus.
Minus and plus. Okay, good. All right, who's getting kicked out of the domain? 1. Anybody else? No, just 1. Why 1? Because it makes this. Why are we leaving out 1? It's because it makes your denominator 0. Thank you. All right. 1 can either become a whole or a vertical asymptote. It cannot be both. Nothing cancels, so there's no whole. Instead, 1 is going to be the vertical asymptote. All right, horizontal or slant asymptote. Compare the powers. Slant, perfect. Put 1 in the little box. Is your countdown in order? Yes, 1, -1, -2. Go ahead and divide it out. You really only need to do the first 2 columns because we don't use the remainder anyway. Oh, and actually that's 0, isn't it? So it's going to be y equals x. Plus nothing. You could write plus 0 if you want to. Yeah, look, it's 1x. Oh, y equals x. How would we graph that? Yeah, it's going to start at 0 and then have a slope of 1. So you would just go up 1 over 1. You can do that. I believe in you. All right, x-intercepts. You would set this whole thing equal to 0 If you multiply over this denominator, it's gonna be gone. So it's really just these equal 0. So you're actually gonna get 2 x-intercepts, one for each of the factors. What's one of them? Yep, 2 and -1, good. 2, 0, and -1, 0. And then you can put those on your grid. Again, try to build the graph like as you're going. Like every time you write something over here, go put it on the graph, unless it's none, obviously. And then how do you get the y-intercept? Plug in 0, perfect. If you plug in 0 for x, now you can either plug it into the original one or the factored one, it's not gonna make a difference. Sometimes I think the original one's easier because you can just cover up x. Like if all the x's are 0, it's like they're gone. So what's left? Yeah, it's -2 over -1, which would just be 2. So 0, 2. And then you can connect the points and just don't run into the asymptotes. So this one's gonna look something like this. Do you see how I'm just connecting the points and following along the dotted lines? Like that's all you're doing. You're just coasting along them. Looks like a great big X or something. That's cool. That's a cool graph. I like that one. And then once you have that visual, you can go pick up the last stuff. Range is kind of interesting in this one. What's our range? Yeah, like if it's everything, how do we write that? Perfect. Yep, every number in existence, which is cool. Like when you scan downwards to upwards, you don't lose anything. All right, reading left to right. What are we doing? Increasing. Decreasing is none or whatever you want to write on that line. What do you copy over for increasing? The domain. Just copy what you had. And then set up your end behavior. And if you want to cover up the middle of the graph so you can see the ends more clearly, I think that really helps. Because there's arrows everywhere, right? Like which ones are you supposed to look at? Look, I'm covering up the middle. Just look, it's very visual. Where's the left side go? Yep, negative, right side, positive. Here's what I'm gonna have you guys do with your group. Do number 10, please. I'm gonna fill in 8 and 9. When I'm done filling them in, that's when we'll go over it, okay? Yeah.
No. Jacob, no way you're doing that.
Yeah, kind words only.
Come on. You don't know what he's after. You don't want to. You know how to do? No, I don't.
Well, I'm gonna take a picture and put it on Schoology once I'm done filling it in. Yeah, just do what you can because I don't want you to like not be able to write later on in the day. I always post everything, so you'll have access to all of it. So you can just talk to your group mates and they can do the writing.
Why is she doing
Hey guys, are you working on number 10? Do number 10. I'm just filling these in so I can take a picture and put it on Schoology for you. You guys are supposed to be doing number 10. I told you I would start going over it once I finished these. Do we want to check the factoring to make sure you guys have that right? Before we move on. Okay, how does the numerator split? It's going to be 2x and 1x. How did you split 4? I agree. All right, and then x squared minus 16. Good. So who's getting kicked out of the, we'll just go over it. Who's getting kicked out of the domain? -4 and correct. You want to do this before you do any crossing out. You have 2 troublemakers, -4 and +4. So what can they now become since we kicked them out? Holes, vertical asymptote. One is going to be one of those and the other is going to be the other. Which one's going to be the hole? 4, good. And so -4 is the asymptote. So how do you get the other part of the hole? Yeah, plug it in to what's left. All right, here's what's left. If we plug in 4, 2 times 4, 8 plus 1, 9, and then down here 4 plus 4 is 8. Don't be surprised if you get a fraction. The whole problem is a fraction, okay? It's not going to be perfect, but like whereabouts is 9/8? Like what's it super close to? It's just above 1, right? Because 8/8 would be 1, so 9/8 is going to be like right above 1. So right near 4, 1, you're going to put a hole. Good enough. It is like good enough. Don't panic about it not being perfect. It's good enough. Compare the powers. Will this be horizontal or slant asymptote? Horizontal. Do you see how the powers are the same? What does that mean you use? Good. It would be 2 over 1, which just is 2. So y equals 2, and then you can dot that in. I only dot them at the edges. This one you actually could put the whole way through. It's not going to cross it, but I just always put it at the edges. All right, x-intercept. You would take this and set it equal to 0. But if you multiply over the x plus 4, it's still just going to be 0. So what will this give you? If you set this 2x plus 1 equal to 0, what do you get? -0.5. Perfect. You're setting this equal, you're setting the whole thing equal to 0, but it's just the denominator goes away. So it's just 2x plus 1 equals 0. You subtract 1, divide by 2. That'll be like right about there. How do you get the y-intercept? Plug in 0. It doesn't matter if you plug it into the factored or the original one. It will not make a difference. 1/4. Perfect. Don't be surprised if you get a fraction. The whole problem is a fraction. And when you connect this, what do you need to make sure you connect? Connect the whole to the graph. For the love of my sanity, please do not leave it floating out in space. And once you have that drawn, you can go back and get everything else. Range, downwards to upwards. What is getting left out as I scan? Look, just but before 2. Because you have to do it in order, smallest to biggest. What do I get to that's getting left out first? 9, good. You guys have got that. It's the y part, 9/8, and then 2. So you are gonna leave out 9/8. Why? Why are we leaving out 9/8? The whole, it's like literally missing. And then 2. I'm sorry, I ran into the grid. I apologize. We left out 9/8 and 2. Reading left to right, what's the graph doing? Doing what? Increasing. What do I copy over for increasing? Just copy the domain. It is the exact same answer. Decreasing is none, or nope, or frowning face, or whatever you feel like putting on that line. That's part of the range. We're copying the domain. Yeah, so we're leaving out 9/8 because there's the hole, and then 2 because it's the horizontal asymptote, so it's never going to run into that. It's kind of like leveling off there, but it's never going to actually touch, so we have to leave it out. I'm sorry, let me write that up here on the board because I ran into the grid. So we're leaving out 9/8. Are you having trouble seeing? Yeah. Okay. Did you drive here? Did you drive here? No contacts in, okay. All right. And then end behavior, where are both of these gonna level off? Good, Y2, whoever said that, thank you. Because that's where the asymptote is. Will it ever actually touch 2? No, it is the behavior.